Hey guys, we're going to continue our journey of Unit 4. We're in Topic 3, which is Ionic Names to Formulas. But we're going to do Part 2 now. We're adding this thing called a polyatomic ion. And I'm going to talk in a second about what that is. Let's refresh what we've done so far. So far we've talked about ionic compounds. And this is when you have a cation, something with a positive charge, attracted to an anion, something with a negative charge. And this is going to be that whole opposites attract. This is a Coulombic force, so that's when two things, when they're really close that have opposite charges, they end up pulling together. When we write the formula, this is the formula unit is going to be formed, so that's the compound, so the basic lowest whole number ratio. So for example, CaCl2, this is the formula unit. And you can think of it as the formula, but why we call it the unit is this is the lowest whole number ratio of it. So that's the formula unit of calcium chloride. So calcium chloride is an ionic compound. It's got something positive, so each calcium has a 2+ charge, and each chlorine has a -1 charge. And there are attractions here, right? So this is your basic unit of it. Now it actually makes this whole crystallized structure, and there's a whole bunch of ions. This calcium is going to be attracted to a bunch of chlorides. Each chlorine is going to be attracted to a bunch of calciums, but overall, this is the unit structure. So it's built out of a 1:2 ratio of calcium to chloride. So far, this is what we've done, and we've had metals bonded to nonmetals. But now we're going to bring in a different kind of ion. So this is a metal ion, and these are nonmetal ions. So now we're going to talk about this thing called a polyatomic ion. And you might have heard of a polyatomic ion before when we talked about drawing Lewis dot structures. So poly, the prefix poly means many, like a polygon has many sides. When we say atomic, we're talking about atoms. And then when we say ion, has a charge. So it's many atoms that have a charge. All right, so let's give an example. An example is ammonium. Ammonium is NH4, but overall it has a positive charge. So it's a bunch of nonmetals that are covalently bonded together, but has an overall, this has a deficiency of electrons because it's positive. If it was negative, it would have extra electrons. So this is, ammonium is an example of a polyatomic ion. It has covalent bonds, meaning it's sharing electrons. We did that last unit. Covalent bonds holding atoms together. It always acts as a group. And has an overall charge. So if you don't look at the charge up here, you can see the formula. It's NH4, and then the charge is written on top. This has a +1 charge. We know it's a 1 because there is no number there, so we can assume 1. What ammonium looks like is it's a nitrogen with 4 hydrogens bonded together to it. And then this whole thing always moves as a group, and it has a positive charge. So this is a cation because it's got a positive charge. So we can use ammonium in our ionic compounds, and that can be your the cation part of your salt. So for example, we could have ammonium chloride. So ammonium, we now know if we break it up like we did before, we know that ammonium has an NH4 positive And then just like I did when I had my binaries, I'm going to circle this whole formula here. So this acts as one unit, so I'm going to circle it just like I did when I just had my singular metal that made a charge. Chloride is chlorine with an IDE, so if you see IDE, I'd love for you to look at the periodic table. And I'd know if I look at the periodic table that chloride is Cl with a negative charge. We did that in the last set of notes, so if you didn't know how to get the charge from chloride, please look at the last set. These will go ahead and cancel out, positive 1, negative 1. So this has the formula of, I have an NH4, and I have a chlorine. So this is the formula for ammonium chloride. Notice I did everything like I did in the last set of notes, except for NH4 with the positive charge. That all goes in my cation circle. So this is acting as one unit. Let's do a different one. What if I had ammonium sulfide? So I know ammonium's formula, we just went over it, it's NH4, and it has a positive charge. Sulfide with the IDE, if it sounds like an element, sulf, and then IDE, I'd love for you to look at the periodic table. And if you look at the periodic table, you know that sulfur has 6 valence electrons, it's going to gain 2, so each sulfur has a 2 negative charge. Now positive 1 and negative 2 don't cancel out, so I'm going to look at my total charges now. Overall on my positive side, I just have a positive 1. Don't be alarmed by this 4, that's telling you how many hydrogens. That's written down below. It doesn't interfere with this charge, so this is a plus 1 overall charge. Over here, this is a plus 2 overall charge, so I can see that these aren't balanced. I'm so sorry, this is a negative 2. I can see that these aren't balanced. I need more ammonium. So I draw that. Positive 1, positive 1. This gives me positive 2. Now I'm equal and opposite, so I can write my formula. So out of these NH4s, I have 2 of them. Now that means I need to say I have 2 of my singular nitrogen and I have 2 of my 4 hydrogens. So what you do is you put it in a parentheses, then you add a 2 outside. And this says I have 2 of everything inside. Sulfur, I only have 1, so just an S. All right, so here is a rule. If you have 2 or more, this only happens if you have 2 or more. So maybe draw some stars around that. This won't happen if you have 1. 2, 3, 4, 5, a million. If you have 2 or more polyatomic ions, needed to balance charges, write the formula for your polyatomic ion, and put in parentheses with how many polyatomic ions outside the parentheses. So this is the rule. If we didn't follow this rule, let's say I had written, okay, I have NH4 and I have 2 of them and I just popped a 2 right there. And then I put my sulfur. This would say that I have 1 nitrogen and 42 hydrogens, which is not true, right? I have a nitrogen, 4 hydrogens, so that's 8 total. So this does not work. What this 2 does is it distributes into it. So if I have NH4 in parentheses, 2s. What this means is NH4, NH4, S. So see how I have two groups of ammonium because there's a 2 outside the parentheses. So that tells me everything inside the parentheses, I have 2 of them. If you're one of my students, you're going to get a polyatomic ion list that looks like this. If you are not one of my students and you're just looking at this video online for a little help, I suggest you take a screenshot of this so you have a pretty extensive list of polyatomic ions. So this is broken up by charge. It starts with the 1 - charge here and continues to 1-. Then you go to 2-, continues over here 2-, 3-, 4-. Notice that we only have 2 positive polyatomic ions. There might be more out there, but you're rarely going to see them, certainly not in a general chemistry classroom. Phosphonium, you barely even see in Gen Chem on practice problems. Just be aware it's there. So ammonium is the main cation that you might see at the beginning. That is a polyatomic ion. For these, if you notice, really often this will end in ATE or ITE. If it ends in IDE, like amide, right, you might be thinking, oh, IDE, I'd look at the periodic table, but AM is not the start for any non-metals. Let's go over that. So polyatomic ions that are anions, meaning they have a negative charge, a lot of them are going to be oxyanions, which means that they contain oxygen and then something else. So for example, nitrate is a polyatomic ion. And from the word nitrate, this tells you that there is a nitrogen. Usually, if we had a nitrogen ion, we'd call it nitride with an IDE. But this ATE tells you that there is oxygen involved. Nitrite has a formula of NO3-. So let me show you where you would find that on the list I gave you. If we look here, so it's NO3-, so I go to the -1, and then I go down to N, so that's right here, and nitrate, NO3-. Notice we also have nitrite, NO2-. So this is another oxyanion, so you have to be careful about your endings, ATE versus ITE. They could change. We're also going to have peroxy, but then 8s, so here's a peroxide, some other tartrate. See, we've got a whole bunch of different endings. Here, amide, like I mentioned earlier, you don't see ATE or ITE. You've got the ending IDE, and that just is saying, okay, it's an anion with no oxygen. So the ATE, ITE endings are telling you that there's oxygen involved. Another one you might see, for example, so you might see peroxy disulfate. We can tell that this is certainly not just one metal, right? Sulfite or sulfide is something we've seen before. Sulfide is sulfur with an IDE, so it's just sulfur with a charge, and this is sulfur 2-. We did this earlier today in the notes, and you saw this in the last set of notes. So this is just a non-metal anion. It's got the prefix of the non-metal and then the ending IDE. So this is what we learned about last time. But now we have these other endings which tell us, let's look at our polyatomic ion list. So go ahead and look at your polyatomic ion list if I gave you one, or go back to it, but we can see that this is S2O8 with a 2- charge. These are the two I'm going to use for the next two examples. Let's say you're given aluminum nitrate, and you're told, I need the formula for aluminum nitrate. We're going to do things exactly like we've been doing them. So we're going to separate the cation and anion. Aluminum we know is a metal, so we have to look up what charge it has. There's no Roman numeral after it, so that means it's got a definite charge. It never changes. So you find aluminum on your periodic table, and you know based on its placement, aluminum makes a 3+ charge. If you don't know how to find that charge, please, please, please come see me for help on how to find this. Nitrate, the ATE, is a clue to go to your polyatomic ions. So if it ends in ate or ite, ATE, ITE, then you're always going to go to your polyatomic ion sheet. Let's write that. ATE or ITE, this is always a polyatomic ion. The other way it could end in IDE, but not a nonmetals name. This is also a polyatomic ion. Like cyanide, this has the IDE, but there's no element with that name. So that's how we know it's a polyatomic ion. All right, this one, nitrate, the ATE tells us, look at your polyatomic ion sheet. So we look at it and we find nitrate is NO3 minus. I circle this whole thing. 3, 1, not equal. So I have to do my total charges, 3 plus, 1 minus. So I can see I need more nitrates. NO3 minus. This gives me 2 minus. So I'm not quite there. NO3 minus, add another one. This is 3 minus. Now I'm equal and opposite. So I say, well, how many aluminums did I draw? I drew 1 aluminum. There's only one thing circled. For my nitrates, I drew 3 of them, which means that is 2 or more. So I need parentheses, NO3. And then I say, okay, I have 1, 2, 3 of them. So in the parentheses is the exact formula that's inside your circle, just you don't write the charge. And then outside you put the 3 because that's how many you drew. So here's that formula. Let's do one more. What if I had lithium peroxy disulfate? Okay, separate. Lithium is a metal, so you find it on the periodic table. It does not have a Roman numeral, so you know the charge is always the same. Lithium, I can find it, and I know it makes a positive 1 charge. Peroxy disulfate, 8 is your clue to go to your polyatomic ion list. And we went through this earlier in the notes. This is S2O8 with a 2 minus charge. When you're drawing these, it's really important to be very clear about what number goes down below and what numbers go up top, because you don't want to confuse this 8 and this 2. All right, this is 1, that's 2. Those are not equal, so I'm going to keep track of my totals. So I've got 1 plus, and I've got 2 minus, so I need more on this side. I'm going to add another lithium. This gives me 2 plus. These are now equal and opposite. They will cancel out, so overall I have no charge on this whole molecule. I'm so sorry, it is not a molecule. Molecules have covalent bonds. On this whole formula unit, I have 2 lithiums, so this is Li2. I have just one of these. I keep my subscripts, S2O8. Since I only have one polyatomic ion, I don't need a parentheses. The parentheses would only say I've got multiple groups of this. So make sure you always write the formula that's inside your circle exactly as is. You only do parentheses if you drew multiple. I didn't draw multiple, so this is done. Here is the formula for lithium peroxy disulfate. I need 2 lithiums and 1 peroxy disulfate to come up with this. All right, guys, good luck with using polyatomic ions to come up with your formulas. Make sure you sign into office hours or talk to me if there's anything else I can help you with. Otherwise, I'll see you in the next set of notes.